Hey guys, it's me, Dan from Sequence Engineering, and today we're going to do some math. I know that that is terrifying for some of you, but I promise it will be simple and it will be helpful. I routinely get requests from our customers asking me to help them size a charger to a specific application, right? Think about all the reasons why you would need to size a charger. You might be looking at a Multiplus inverter charger and you need to know that you're going to have the charge capacity that you want in order to recharge a battery bank over a given period of time, or you're trying to charge your battery bank using a solar charger, and so you need to figure out what size solar charger you need in order to efficiently charge your battery bank over a given period of time. And so we are just going to spend a few minutes running through the math that you need to do in order to determine what size charger is going to be best for your application. All right. Now, this is going to be oversimplified and it is going to be very basic in nature, but stick with me and you will get the overall premise of what we're trying to accomplish and what you need to do in order to do this math on your own. So up here, we're going to start with some very basic premises, okay? Basic understanding of where to start. All right, size my charger, okay? We must remember watts equals volts times amps, all right? You are going to use this equation over and over and over as we walk through this process, okay? So watts, volts, amps, all right? I'm even gonna write it below so that you remember. Now, as we remember from middle school, if we want to solve for one of these variables, we must know two others, all right? So we're going to do a very basic equation here, and I'm going to walk you guys through kind of the process that we're going to follow as we learn more about how to size a charger, okay? So let's say I have 1200 watts. That could be solar or AC input or anything, okay? And I'm charging a what type of battery bank? This is typically going to be 12, 24, or 48 in the environments that we are operating in. Let's say it's a 12-volt battery bank, all right? 12 volts times amps. Amps is actually what we're trying to solve for, okay? So we want to know how much current do I need in order to charge that battery bank utilizing all that wattage. So what we're going to do here is we're literally going to divide by 12, okay, because we remember that from math class, and our answer is ultimately going to be 100 amps. Now, if I need 100 amps, I've got to find a charger that is going to give me 100 amps of charge current. Now, as you guys remember, a lot of the Victron chargers in the MPPT world, they are actually rated as such. Okay, now we're going to jump into a real world example. Okay, we are actually going to size a solar charger. Now again, this is going to be very basic and we are not going to take temperature into account or many of the other factors that you might want to look at, but this is going to give you a feel for how you would actually size a charger to match up to how much solar you actually have. Okay, so let's say we have 400 watts of solar, all right? That is a very common situation in the recreational RV world. Okay, we have 400 watts of solar. What size charger do we need? I am going to ask another question because it is critical to getting the answer that we want. We know that we have to understand our voltage. Now, the voltage in this environment is probably going to be 12, 24, or 48, but you must know the answer to that in order to solve this equation. So we're going to assume that we are operating at 12 volts, all right? And we're going to solve for our current, which is amps. Now, I'm going to give you guys three options to choose from for a solar charger that is very common in the Victron infrastructure. Over here, I have a Victron 130, a Victron 150, and let's go with a Victron 150/60. Now, it's important to take a pause right here and understand how Victron labels their MPPT charge controllers. The front number, the first number, is the maximum allowable input voltage that you can send at the charger without frying it. So 100 volts, 100 volts, 150 volts. The second number is actually the charger's capability in terms of how much current it can charge your batteries with. All right, so this 130 is a 30 amp charger. Okay, now you can use the 30 amp charger at 12 or at 24 volts. Not many of their chargers are rated for 48 yet, but most of them are rated for 12 or 24 volts. So we're now going to solve this equation. The way that we solve this equation is the exact same as our previous example. We're going to divide 400 by 12, and that is going to give us, let's take a look here at our calculator, 400 divided by 12 is 33.33. Okay. All right. So which one of these chargers would you select for your application? Me personally, I'm going to select number 2, right? Because it has more charge capability than I need, right? 50 amps, and I need 33 just to utilize the amount of solar that I have. I also know that my system could operate slightly more efficiently in cold weather, and so I am going to go with the slightly larger charger. You now can do this math again at a different voltage to see how the math changes, okay? So let's do that real quick, and I want you guys to tell me which one of these chargers you would use at 24 volts, okay? So I'm gonna go ahead and erase this, and I'm gonna erase that, and I'm gonna erase this, and I'm gonna show you guys why voltage matters so much. Let's say I have 400 watts of solar, but I'm operating a 24 volt system. I have a 24 volt battery bank, okay? I'm gonna write 24 right here in the voltage spot, and I'm going to put 24 down here, and we're going to do that math again. 400 divided by 24 equals 16.66. Now, what did you guys notice? Our current dropped in half, right? Because our voltage doubled, our current dropped in half, okay? Now, what does that mean for chargers and how you would select your charger? Well, if you take a look at 16, it's a lot smaller than 30, and it's highly unlikely that we're going to send more than 100 volts at this charger. So because we are using a higher voltage battery bank, we can actually use a smaller charger, right? So this is critical to understand when you are sizing solar chargers or DC to DC chargers or Multiplus inverter chargers in the field. There are benefits to operating at higher voltage, and you guys just witnessed one of them. Okay, so you can operate at lower current, which also allows you to operate at smaller wire, and you can utilize a smaller charger to achieve the same result. Now, I want to move over to a slightly different application and run you guys through the math on a very common Multiplus unit, okay? The Multiplus unit is actually going to give us the ability to do some math on the input and the output. And it's very intriguing to see how this math shakes out. So we are going to do the math on a Multiplus 12, we'll say 2, 12, 3000-120. Okay. Now, as we look at the nomenclature and how Victron has labeled this product, it's important to note that this is a Multiplus 2, which signifies that it is an inverter charger. It's going to operate at 12 volts. It has the capability of producing 3,000 volt amps, and it is a functioning 120 amp DC charger. Okay, so remember that. Remember the 120 amp DC charger. Okay. So I'm going to draw a Multiplus. You guys are going to be amazed by my artistic abilities. All right. And I'm going to draw AC in here, AC in, and I'm going to draw DC over here. Okay. Plus and minus. All right. And I'm now going to talk through how this inverter charger works, okay? So this inverter charger is going to convert AC to DC power, right? You guys all know that. But what voltage is the AC input coming in at, right? More often than not, if we're running a single Multiplus in the US, especially this one that's also rated for 120 volts, left that part out, okay, 120V, all right. This is the power that's coming into this unit is gonna be coming in at 120 volts, okay. Now, when you go to program this unit, you can set the input charge current at a level that is going to prevent you from tripping your breaker over here, okay? So more often than not, people will leave it at the stock setting, which is typically, I think, I don't know, 50 amps on the input. If I were to allow this unit to draw 50 amps at 120 volts, we know that watts equals volts times amps, right? Watts equals volts times amps. Okay, so I'm going to say 120 times 50 equals, all right, whoop, 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 6,000 watts. Okay, so this thing could potentially pull in 6,000 watts. Now, over here, we know that this is a 120 amp DC charger, don't we? Because the name tells us that it's a 120 amp charger. All right, so I have 120 amps. The other thing that we know is that we're operating in a 12 volt system because we have a 12 volt Multiplus unit. So over here, the maximum ability that this thing can send to my batteries, all right, the maximum watts that it can charge my battery bank with is watts equals volts times amps, right? It is watts equals, I've got a 120 amp charger and I'm charging a 12 volt system. So it's going to be 12 volts times 120 amps. And I apologize for my handwriting, right? That is going to equal 1,440 watts. Okay, the absolute maximum wattage, this Multiplus 123000-120 120 volt inverter charger, the absolute max that it can charge my battery bank at is 1,440 watts, okay? Now, when I go to program this unit, if I don't see a world where I'm going to use the 50 amp transfer capacity of this unit, is there any point in me setting this unit to 6,000 watts or 50 amps as it comes from the factory? The answer is not really, right? So we see a lot of clients, especially in the camper van world, they will put a 30 amp input on the side of their camper van, and then they will think that they could use a 12 volt Multiplus inverter charger to send 30 amps worth of charge, downstream to their battery bank. And you and I just did the math to determine that we cannot do that, okay? So the maximum amount of charge current that we could actually utilize for the charger is in and around 14 amps, okay? So let's take a look at that. Let's say watts equals volts times amps again. Let's say we know that we have AC power coming in at 120 volts, and we're going to say that's times 14, okay? Abracadabra, the math is the same, all right? So you have 1,440 watts on the in, and you have 1,440 watts on the charger, okay? So if you wanted to match those two things together for this particular Multiplus 212-3000, that's kind of what the math looks like. Now, because it's super duper fun doing math, we can do the exact same math on a different Multiplus unit, okay? So let's take a look at a 24-3070, all right? So the 24-3070 is still going to be a 120 volt unit, but the math is going to change. So now the math is you still have 120 volts on the input. You still have a charge current up here in the nomenclature of the unit. So we have maximum charge capabilities of 70 amps, but that's 70 amps at 24 volts. So our maximum charger wattage is 24 times 70, okay? And 24 times 70 is 1680. Interesting note is that on the higher voltage unit, you actually get a slightly higher rate of charge, right? 70 amps at 24 volts is higher than 120 amps at 12 volts. So pretty intriguing there. And so over here, when you go to program this unit, you're actually going to program it slightly higher than you would the 12 volt version, right? Because you can actually utilize 1680 watts. So over here, you're still going to have that 120 volts. You now are going to solve for what you want your input charge current to be to match your charger's capability, which is 1680. All right, so we literally just going to do 1680 divided by 120, and that is going to give us that 14 amps again. That is kind of a good way to look at how you would size a inverter charger for the application that you want to use. In addition to that, you also could look at this being a generator, right? And where that gets interesting is if you know that you have a charger capable of charging 1680 watts and you have, let's say, like a 4,000 watt generator, those two things don't line up very good, right? So if instead of being plugged into shore power over here, let's say you're actually plugged into a generator, what size generator would you want to put over here in order to maximize your fuel usage in a situation where you're using this as a charger of a battery bank? Well, we know, right, that generators typically like to operate in and around 80% of their rated capacity. So if we have 1680 watts, right, we probably want a generator that's in and around 2,000 watts or so on the input side in order to actually utilize the charger in an efficient manner. You can do this math over and over and over again, and the key to success here is just to remember that watts equals volts times amps, and that you constantly want to match your input watts to your charge capability, right? And vice versa, okay? So if you've got a solar array that's a specific amount of wattage, you simply do a little bit of math to determine the right size charger. If you already have a charger like we do here, and you need to size your input like a generator, then you simply are going to do that math in reverse, and you're going to figure out what the most efficient generator that you could go find is for your particular application. So hopefully that's helpful to you guys. Hopefully that helps you guys establish kind of how to size a charger and how to match a charger to a specific amount of wattage that you have on the input side. Let us know if we can help you in any way, shape, or form. This is kind of what we do all day, every day. So give us a shout or reach out, and we're here to help.